Hello, good morning, my dear students. Welcome to the chemistry class. Once again, myself I am Arifadli. In the last class, we have begun the new chapter, that is chemical kinetics. Today we will see the next content. So we know rate of the reaction is nothing but which can be expressed in the form of reactant and also product. Here, rate of the reaction is nothing but we are writing the rate of the expression minus dr by dt, means concentration of the reactant decreases or concentration of product increases with respect to the time. This is called as rate of a reaction. Here, what are the factors influencing the rate of reaction is nothing but some of the factors may increase the rate of reaction. What are those factors? For example, first one is concentration of a reactant or pressure of the reactant. Initially, the concentration of the reactant is more. As the concentration of reactant is more, the rate of the reaction will be faster. Means reaction is fast. Hence, we are calling that as rate of the reaction is fast. Pressure of a reactant. If the pressure is more, the reactant will be the faster to form the product. Therefore, next one is temperature of the reaction. As the temperature is greater, the rate of the reaction increases obviously. And presence of catalyst. Means in the catalyst, no doubt in all of the reaction, the catalyst increases the rate of reaction, means speed of the reaction increases by using the catalyst. In some of the reaction, very negligible or different kind of the catalyst decreases. Wherever we are using the catalyst, we are using the catalyst only because to increase the rate of reaction, means speed of the reaction increases by using the catalyst. Next one is surface area nature of the reactant. Here surface area nature is nothing but think that it is a reactant and one more reactant is going to be react or collide or bombard with the reactant. If here two reactants are colliding or reacting each other, means one of the reactant should have the greater surface so that another reactant will easily combine with each other. Therefore, the surface area nature of the reactant is influences to the rate of reaction. Means surface area is greater, means the rate of the reaction increases. Next one is exposure to radiation. Whenever we expose some of the reactants to the radiations, if the reactants are ready to activate easily, such kind of reactants are more reactive to form the product. Therefore, exposure to radiation is important to increase the rate of reaction. So, these are the factors which influences the rate of reaction. It will be asked for 2 marks, right? The factors which influence the rate of reactions. Or they may ask how the concentration of the reactant influences, whether the concentration of the reactant increases, rate of the reactions increases. Such kind of applied question may ask. Next one, it's a heading, rate expression, rate constant and rate law. These three are interlinked together each. Therefore, rate expression is nothing but we can say the expression of rate by using, consider the general reaction, the reactant AB, it's going to give the product C and D. I think you should remember here the small a, b, c are the coefficient factor. To this reactant, to this reaction we can write the rate of the expression. Here rate is directly proportional to the concentration of A and B. Concentration of reactant it is. A and B are the reactant. Means rate is directly proportional to the product of concentration of reactant. Product is nothing but multiplication of the reactant. A, B are the reactant. Square bracket indicates the concentration. Rate is directly proportional to the product of concentration of reactant, where x and y are nothing but here exponent xy, they may be equal to the coefficient a and b, but we are not writing on a, we are not writing the power as a, even for the b we are not writing the coefficient of a, because here x and y are experimentally determined value. It means that here we are writing x and y, how we are calculating means it is experimental value. It is not possible to write theoretically. How we are writing, it will come to know in the next slide. Here, rate is proportional to the product of concentration of A and B. Here, x and y means power of A and B, that is x and y. Here, x may equal to the A or may not. Similarly, y may equal to the b or may not, because x and y they are not related to the theoretically written reactions. These are calculated experimentally. You should remember this one. Next one is rate is proportional to here product of concentration. Proportional can be replaced by the equal by keeping the proportional constant, that is k. Look here in this expression, rate of the expression k is the thing what we are calling this as the rate constant. It will come to know here. Whereas rate is equal to k concentration of E and V. Here rate can be written. We know that rate of the reaction can be written as minus dr, means delta R divided by delta T, or delta P divided by delta T. Rate of the expression can be written in the form of dr by dt. Therefore, here I am writing rate is in the form of dr by dt. Minus indicates the concentration of the reactant is decreasing. And I have written in the right side same as it is. K is equal to K, E and B. These are the reactant, X are the. Look here, in this expression we are calling as rate expression, where in the rate expression the small k represents the rate constant. What is rate constant? Obviously they are not asking such questions, but you should remember in the rate expression the constant k, small k, is called as rate constant, whereas this expression itself is called as differential rate equation, or it is generally called as rate expression. You have to remember that rate expression is nothing but rate is equal to small k into concentration of, means product of concentration of reactant with some powers. These powers are experimentally determined power. You will come to know again. I hope you remember rate expression how can be written, and rate constant is nothing but in the rate expression small k is called as rate constant. Whereas to write it in a rate law, we are using the same expression. Rate is equal to, this is rate expression formula, k into a into b by the powers x1. If concentration of a and b together, if they are having the value 1, means if it is unity, can you see here? If concentration of a and b, if they are 1, means 1 to the power anything, it may be a 0, 1, 2, 3, 4, 1 raised to anything, it remains as 1 only. Therefore, if concentration of both A and B are 1, here square bracket they have given, means concentration of the reactant A and B are 1, then rate, means dr by dt is nothing but rate. I have written rate is nothing but dr by dt. Here rate is equal to k, because these two becomes 1. 1 into k is equal to k. Therefore, why we are writing this only to represent that rate constant. Here rate constant is nothing but k. Rate constant can be defined in the form of rate of the reaction. Rate of the reaction is equal to the rate constant. When, means when the molar concentration of the reactant are unity. I am not showing the power. We are not explaining based on the power, because power may be anything. If the concentration is 1, means base is 1. If the exponent are anything, then the value remains 1 only. Therefore, here if concentration of A and B are 1, then the rate is equal to k, whereas k is the rate constant. Rate constant is also called as rate of the reaction. Based on this expression, we are defining that rate constant is also called as rate of the reaction, which is defined as rate of the reaction when molar concentration of the reactant, molar concentration of each reactant is unity. When the concentration of each reactant is 1, then we are calling rate constant as a rate of the reaction. What is rate constant? What is the rate of the reaction? They may ask you such questions. And next one is, this is important, what is rate law? Define rate law. Here rate law is nothing but it is the expressing or defining the rate law using the rate expression formula. Okay. Rate law is the expression in which the reaction rate is given in terms of product of molar concentration of each reactant raised to experimentally determined power. Means rate law is nothing but it is the product of molar concentration of the reactant which is having, means exponential they are having the power. These power are experimentally determined power. This expression itself is called as rate law. Rate law is nothing but it is expressing the terms of product of concentration, product of molar concentration of each reactant raised to experimentally determined values. This is called as rate law. So this is definition important for 1 marks. You should remember the more important is the rate law is expressed in terms of experimental value. Means I'm once again and again saying you x and y are experimentally determined value, but not they are theoretically. By seeing one of the reaction, it is not possible to write the power of x and y. It's not possible. Means it can be written only by doing the experiment, not by seeing the reactions. Keep in your mind. How we can determine the x and y, means while writing the rate constant, on what basis we are writing x and y powers to the concentration of reactant A and B. You will come to know by one of the experiment. We are not doing that experiment, but we are expressing, we are understanding how it is possible to determine the powers of concentration of reactant. Look here, initially I am giving you the rate law expression. For example, 2NO plus O2, it gives 2NO2. This reaction is having the rate law, which is experimentally determined. The rate law can be expressed by dr by dt, means rate is equal to K into concentration of reactant here. NO, which is having the exponential power 2. Here 2 is nothing but it is experimentally determined value, and another reactant is having the nothing is there, means it will be having 1. O2 is having the power 1. How we are representing this one, 2 and 1? I think it seems to be like a stoichiometric value. Here NO is having the 2, here is also having the power 2. O2 is having the stoichiometric value is 1. Here also it seems to be 1. But we should not forget that it is experimentally determined value. Sometimes this exponent may equal to the stoichiometric value, but not always. It is irrespective of the stoichiometric value. These powers are not related to this one. Sometimes they may equal, but not for all the time. How we are writing this one? You just look at this one. Experimentation to determine the rate law. How we are doing the experiment means, concentrate on the meaning here, whichever I have highlighted. When the molar concentration of only NO is double, can you see these are the two reactants here. Two reactants. In these two reactants, just you look at this reaction. These are two reactants and one product. Between two reactants, we are going to increase the concentration of the reactant of one reactant. We are increasing the concentration of one reactant. One will be keep do not altering. We are not touching another one. We are doubling the concentration of one NO. At that time, we are not touching the concentration of O2. And how the rate of the reaction increasing, we are checking. Another time is we are doubling the concentration of O2. Doubling is nothing but concentration. Whenever I use the word concentration, you have to look that concentration is nothing but you can imagine a quantity. When the quantity of the reactant is doubled, then the rate of the reaction is increases. I am saying that to understand you. You are not supposed to use the quantity word. Concentration is nothing but just you can understand as quantity, but you are not supposed to use that word. Here, when the concentration of NO is doubled, then what happens to the reaction? At that time, we are not changing this concentration. It will be remain initially how much? How was that much? That means remain same as this. And next time we are doubling the concentration of another O2. At that time, we are not changing this one. Then what the reaction will changes? Based on that, we are representing the powers. Just to look here, by this statement, I hope you can able to understand. When the molar concentration of only NO is doubled, can you see here? Only NO is doubled, keeping the concentration of O2 unaltered. We are not changing the concentration of O2. At that time, the rate of the reaction increases by 4 times. The rate of the reaction is increases by 4 times. This indicating that the exponent of molar concentration of NO must be 2. So how we are representing? Just I would like to say you on what basis you have to remember to express. Look here, if any one of the reactant we are doubled, here the reactant NO we are doubling, means concentration of NO is doubled. At that time, rate of the reaction increases. How much it increases? This is what you have to observe here. Look here. The molar concentration of NO, one of the reactant, is doubled, then the rate of the reaction increases by 4 times. If the concentration means the rate of the reaction is increases by 4 times, then we have to write that the power of this NO must be 2. When the concentration is doubled, the rate of the reaction increases by 4 times. It means power should be 2. There are only 3 terms to remember in whole explanation. The one thing is when the concentration is doubled, if the rate of the reaction increases by 4 times, then the power should be 2, means concentration of the NO must be 2. I hope you will get still more understand by the next one. Are you understanding why we have written 2? We are not changing the concentration of O2. When we double the concentration of NO, then the rate of the reaction increases by 4 times. 4 times means we are writing that as the concentration 2 is doubled, means it is increased by 4 times, means power should be the 2. Therefore, next one, to calculate the power of O2, just look at here, you will understand still easy. When the molar concentration of only O2 is doubled, this time we are doubling the concentration of O2. We are not changing this one. When the molar concentration of only O2 is doubled, keeping the concentration of NO unaltered, we are not changing NO. Then the rate of the reaction increases by 2 times. 2 times. The rate of the reaction is increases by 2 times. This indicating that the exponent of molar concentration of O2 must be 2. On what basis we are writing? If the, can you see here also be doubled, here also be doubled, here the concentration is increased by 4 times. If the concentration increases by 4 times, that's why we are writing the power 2. Here also we are doubling the concentration. If we double the concentration here, the rate of the reaction is increases by 2 times. That's why we are writing the power 1. How? It is experimental value. Don't get confused. We have to say that we must and should we have to double the concentration of each of the reactant. Once it is increased, means if the concentration is doubled, if the rate is increased by 4 times, then the power should be 2. The same thing, here the concentration is doubled, then the rate of the reaction increased by 2 times, then the power should be 1. This is how we have to remember this one. Are you getting my point? Concentration is increased by 4 times, then the power must be 2. If the concentration is doubled, then the rate of reaction increased by 2 times, then the power must be 1. Here, only in this expression, we are observing that the exponents and stoichiometric coefficients of NO and O2 are same. Can you see that NO is having power 2 and coefficient is also 2. O2 is having the stoichiometric value 1 and the exponent is also having the value 1. Only in this expression we are having. It doesn't mean that they are interrelated. No, never. They are not interrelated. They are not having any relation between theoretically and experimental. It's purely experimental value. So we will see another example. For the reaction, actually can you see here? Here initially only I have given the rate of the reactions. Means the rate expression I have given. Unless and until without seeing this expression, it is not possible to write this in the sentence, because we don't know how we come to know this. What is the rate of the reaction? How the power is raised 4 times? It's not possible because in our syllabus we are having only this kind of the reaction. That's why you have to practice only this 2 reaction. Here second one is when trichloromethane reacts with chlorine, it gives tetrachloro methane and HCl. Here initially I am not giving you the rate expression. First we will discuss it and later we will write the rate law. Experimentation to calculate the rate law. How we can write this one? Look here, same thing as we did in the previous. Here when the molar concentration of only CHCl3 is doubled, keeping the concentration of Cl unaltered, means we are doubling the concentration of first reactant, we are not changing this one. Then the rate of the reaction increases by 2 times. The rate of the reaction increases by 2 times. It indicates that exponent of this CHCl3 must be 1, because in the previous we have seen that if the concentration, no doubt we have to double the concentration of each of the reactant. Initially if we double means then the rate of the reaction increases by 2 times, means the power should be 1. So it means CHCl3 is having the power 1 in the rate expression. Similarly, we will see the next one. When molar concentration of only Cl2 is doubled without altering the concentration of CHCl3, then the rate of the reaction increases by square root of 2 times. This is square root of 2. The rate of the reaction increases by square root of 2 times. This indicates that exponent of Cl2 is 1 by 2, means half. The power is half. This is new one for you. Look here. If the concentration is doubled, then the rate of reaction is increases by square root of 2 times. Square root of 2 times. It means the power should be half. If the concentration is doubled, then the rate of reaction is increased by 2 times. Then the power should be 1. Similarly, if the concentration is doubled, then the rate of the reaction is increases by 4 times. If it is increased by 4 times, then the power should be 2. These are the 3 terms you have to remember. They may give you this reaction. In your second PU annual exam, you will be having only for this. If in the competitive exam, if you get any of the other reactions based on this expression, you should be capable to write that one. Here, thus the rate expression for the above reaction is, can you see here? Rate is equal to K. I have written CaCl3 power 1. Nothing is written means 1 because it is increased by 2 times. On the Cl2, I have written the power 1 by 2. It is 1 by 2. Are you observing this one? If it is visible means okay. No means you just remember this is power is half 1 by 2 it is. Why? Because by doubling the concentration, the rate of the reaction is increased by root 2 times. Therefore, we are writing the power as 1 by 2. So based on this, you can able to write the theoretical value and you just keep in your mind. Here the exponent and stoichiometric values are not same. Can you see here? Here CHCl3 is having the stoichiometric 1. Here also exponent is 1. Whereas chlorine is having the stoichiometric value 1. If nothing is there means 1 will be there. And the power it is not having 1. It is half. Why means not only this one. All the reactions, the rate expression is not determined theoretically. By saying any one of the general reaction, it is not possible to write the rate expression. It can be written on the basis of experimental rate. Therefore, here it is not same. So based on that, we will finish the second today's class and take it as homework. Try to write this one. And very few of your friends are sending me the written notes or homework, and it's your duty to do the note work and don't write it at the end. I am giving you assignment questions and everything soon after finishing the class. Therefore, along with this homework, better you have to note down the notes whichever I have given in the slides. You just go on making the notes. No need of doing the separate notebook. In the Shubha madam, whichever you have did the assignment and notebook, in that only you just continue. You just stop that 18 group elements. You just continue the chemical kinetics in that one. Later, I will continue the which chapter that is P block units. Okay. We will meet in the tomorrow class. Have a nice day.